Hi everyone, and welcome to the second of two videos on some past exam questions on the topic of shapes of molecules and bond angles. If you've already watched the previous video, you'll notice that a lot of the questions in this video are very, very similar to the ones in that video. They're just sort of worded in a slightly different way. But actually, a lot of the molecules we're going to see here are very similar. There's not that many different molecules they could reasonably expect you to be able to do, and they do get quite lazy with reusing the questions. So this is definitely a topic where you can benefit from practicing these exam questions because you find the same things keep coming up. This first one's a good example. It says state the shape of a molecule of Sf6. Okay, that's an octahedral shape. Okay, that's just one we need to remember. Anything with 6 atoms around the central atom is going to be octahedral. In the previous video, it was just the question that was the opposite way around. It said name an octahedral molecule, and it wanted you to say Sf6. So they're just asking the same question, but the opposite way around. Here it's asking us about Bf3 and Nh3. So again, this is very similar to a question in the previous video. Okay, in that video, it had these two molecules bonded to each other to make one molecule. Here we've got them separately. Okay, so draw dot and cross diagrams for each of these. Okay, so Bf3, we're going to have our boron in the middle, and it's going to bond to 3 fluorines. And we're going to have single bonds. Fluorine, remember, is in group 7, so it only needs one more electron to fill its shell up. Don't forget, as I said in the previous video, make sure you put these extra electrons on the outer shell of the fluorine. I see students missing these off quite a lot, so just don't rush it. And then the boron only has 3 electrons, it's in group 3, so that's fine, that's done. And then NH3, we've got our nitrogen bonding to the 3 hydrogens. Again, these are just ordinary single bonds. Hydrogen only has 1 electron, doesn't it? And then nitrogen is in group 5, so it should have 5 electrons in its outer shell. We've done 3, so we need to put a lone pair on. So there's our 2 dot and cross diagrams. We're going to get 2 marks for that. It's a 5-mark question here, so we've still got a bit of work to do. Use the diagrams to explain why Bf3 has a bond angle of 120 and NH3 has a bond angle of 107. So it's nice that they've told us the values without we haven't actually got to go and work those out. So that's good. So why has Bf3 got 120 degrees? Always, always, always what we want to say is just state what pairs of electrons we have. That's the reason. Okay. So Bf3 has 3 bonded pairs of electrons. Okay, why is that relevant to the bond angle? Well, because those pairs of electrons repel each other, don't they? Okay, 3 bonded pairs of electrons, and they're going to repel each other equally, so they go 120 degrees apart. Okay, whereas when we've got NH3, this has 3 bonded pairs of electrons and the 1 lone pair. Okay, and the relevance of the lone pair is the idea that the lone pair repels more strongly than the bonded pairs. And that's it, that's all we need to put. Okay, so it's about how many pairs of electrons you've got, and it's about how much they repel each other. Right, last bit on this page wants us to do a molecule of CH3Cl. So we've got chloromethane here. So we're going to have our carbon. It's going to bond to 3 hydrogens. And it's also going to bond to a chlorine. It's just going to do single bonds with the hydrogens. And it's also going to do a single bond to the chlorine. And then the chlorine, we need to fill in the remaining electrons on its outer shell. Chlorine's in group 7. Right, that's that done. Name the shape of a molecule. So what have we got? Again, we want to look at the atom that's in the middle for this. So we're looking at the carbon. The carbon has got 4 bonded pairs of electrons. If it's got 4 bonded pairs, then it's going to be tetrahedral. And what would its bond angle be? Remember, 4 bonded pairs tetrahedral, it's going to be 109.5. It's not asking us for that, but this is basically, this whole topic is, can you remember matching up the pairs of electrons, the shape, and the bond angle. Okay, carrying on. Here we've got something that is, again, very similar, but slightly different here. We've got this hydrazine molecule, which is NH2, kind of bonded together. It wants us to predict the bond angle here. Well, the bond angle depends on whether we've got bonded pairs or lone pairs. And the only way we're going to know that is if we draw a dot and cross diagram. Okay, this is the biggest thing that I see people going wrong, is they just try to work this out from here. Okay, if they haven't drawn a dot and cross diagram for you, then you draw one. Okay, so we're going to have nitrogen bonding to 2 hydrogens, and then another nitrogen also bonding to 2 hydrogens. So these are just going to be ordinary single bonds. Hydrogen always does the same thing. Now, what's going on with the 2 nitrogens? Have we got a single bond, a double bond, a triple bond? How do we know this? Because they've shown us here, look, they're showing us it's only a single bond. Yeah, they would have drawn a double bond here if it was a double bond. Okay, so this also wants to be just a single bond. Okay, so then here, what have we got left? Nitrogen is in group 5, we've seen it before. So it doesn't matter, but let's say for the sake of argument, this nitrogen is going to be dots, I've decided. So if I've got 3, if it's in group 5, it needs to have 2 more to get up to 5. And then we've also got 8 in the outer shell, so that works. So then if this nitrogen is dots, I've decided, this nitrogen is going to have to be crosses. So that would be the same, but I'll have 2 crosses here to represent the lone pair. Okay. Right. So then we've got 4 marks to get here. They're not going to give us any marks for this. They didn't ask us to draw a dot and cross diagram. So this isn't going to get us any marks. This is just our working out to be able to do everything else. Okay. So in hydrazine, the nitrogen atom has 3 bonded pairs and 1 lone pair. Okay, so we're going to get a mark for that, for saying what pairs of electrons we've got. Okay, why do the electron pairs matter? Well, the whole point of this topic is the electron pairs repel each other, don't they? Okay, so 3 bonded pairs and 1 lone pair. The electron pairs repel, and you must always say electron pairs. Okay, just saying electrons isn't going to be good enough. The electron pairs repel, and the lone pair repels more strongly than the bonded pairs. Okay, so we've explained that, and then finally it wanted us to actually say what the bond angle is. Okay, so the bond angle, if we've got a total of 4 pairs of electrons, so we'd expect it to be tetrahedral with 109.5, but because the lone pair repels more strongly, it's going to reduce the bond angle, and it reduces the bond angle by about 2.5 degrees. So we'd expect the bond angle to be 107 degrees. Okay, and it's not asking us actually for the shape, but it would be a pyramidal shape. We wouldn't need to write that, but again, it's useful to help you remember. Okay, one more. All these questions follow the same kind of pattern. Here's some sort of molecule, draw a dot and cross diagram, work out what the bond angle is going to be. Okay, you can see in this one they've asked you to draw a dot and cross diagram first, okay, because that's how you work it out. Here, they didn't ask you to draw a dot and cross diagram, but do one anyway, because that is the method that you use to work it out. Okay, so don't worry about, oh, I haven't actually been asked to do it, just do it anyway, because otherwise you might make a mistake. Here we definitely need to draw a dot and cross diagram. So we've got F2O, so we're going to have our oxygen in the middle, bonding to the fluorines. Fluorine only ever just makes a single bond because it's in group 7. So it's got its 7 on its outer shell. And we're going to have another single bond here. And then oxygen is in group 6, so it's got 2, 3, 4, 5, 6. And then we can just check that these all have 8 in their outer shell. Okay, we know that 8 in the outer shell isn't quite a 100% rule like it perhaps was at GCSE. We can have atoms that don't have 8 electrons in the outer shell, but it is still a stable electron configuration. It is something that atoms will aim towards if they can achieve 8 in the outer shell. Okay, most of the elements that don't have 8 in the outer shell is just because they can't realistically get there. It's still something that we want to use as a rule for a decent chunk of the time, if not 100% of the time. Okay, now we want to predict the bond angle. So for this, we always want to talk about what electron pairs do we have. Okay, and which do we look at? We always look at the atom that's in the middle. Okay, so the oxygen atom has 2 bonded pairs and 2 lone pairs. Why do the pairs of electrons matter? Because the electron pairs repel. Okay, we always follow the same format with these questions. You'll see we're answering exactly the same way that we did for the first one. What pairs of electrons have you got? Say that they repel each other. Why does a lone pair matter? Because it repels more strongly. They're very sort of formulaic, these questions, which is nice because at least it's consistent. You know what you have to do on these questions. Lone pairs repel more strongly than bonded pairs, and then it wanted the bond angle. So this is just, again, have you learnt what it is? If you've got 2 bonded pairs and 2 lone pairs, bond angle is going to be the same thing. It would be based off a tetrahedral structure because we've got 4 pairs of electrons, but every time we have a lone pair, it reduces the bond angle by 2.5 degrees. So it won't be 109.5, it won't be 107, it'll be 104.5. And it would be a non-linear shape. Again, it wasn't actually asking for the shape, but it's useful to try and make sure you can match up the electron pairs, the angle, and the shape.